Thank you. Very much to the panelists and those who asked questions. We'll now continue with the next presentation, the keynote speaker, six or half dozen why Internet Standardization Matters. So allow me to invite Paolo Lucciatente to come up. He is a member of the Network Tools team. Paolo will be sharing with us his experience of Internet standardization from different standpoints.
Thank you.
Right.
And to change the slides? Yeah. Fantastic. And it's... Yeah. Okay. Okay. Perfect. Oh, I did press another button. I don't know. I did press some other button. Ah, okay, okay. It's fun. Yeah, fantastic. Thank you. So, good morning. Bon dia. Buenos dias. It is a great pleasure to be in front of each and every of you and share some of my thoughts about Internet standardization today. These thoughts, they were fostered from something very simple, so from how we can express the same meaning in two different ways. We can say 6, like the number of Grand Prix that Ayrton Senna did win at Monaco. Or we can say half a dozen, like the standard portion of the mini pão de queijo here in Brazil, the Brazilian cheese bread, which if you didn't try, please give it a try. But I tell you, it's very addictive food. I love them. So we will talk also a bit about ITF, which is the main body involved with the Internet standardization. But so let's go with order, because I would like first to introduce myself. Yes, I was not seeing the slides. So I'm Paolo Lucente, and I am Italian, and but I live between Barcelona in Spain and a cidade maravilhosa, Rio de Janeiro, here in Brazil. And I have data collection in my DNA. I've been doing data collection in a form or in another for the past 25 years, essentially. I work for entity data for the global IP network, so the global tier 1 IP carrier of the group, where I lead the effort of data collection and big data. I'm also the author of the free open source tool PMSCT, which is a data collector. I will spend a slide later about it. And I am co-chair at the Grow Working Group at ITF, where essentially the operational challenges associated with the global IP routing system are discussed and documented. I'm also a great community guy, so I am a co-founder of ITNOG, which is the Italian Network Operators Group, and NetBCN. NetBCN, it's like a little NOG, Little Network Operators Group for the city of Barcelona. Maybe next a NOG in Rio? I don't know. Let's talk about it if you are interested if you live in Rio. I would like to start taking your mind to a different scenario than today. Today we are in a huge meeting room. I would really like to take you to a small conference room where maybe there are 50 people, and there is no clapping of hands, not at the beginning and not at the end, where when you are talking about something, maybe you have 5 to 10 minutes, depending how much you have to say. And when you are talking, and when I'm doing it right now, I'm scanning the audience a little bit to see what's going on. I mean, you treasure every single nod that you can see in the audience, any small sign of support or of approval of what you are saying. Why is that? Because each of those 50 people would be contributors to protocols that are foundational for the internet, either for its operation or its monitoring. And protocols that maybe there is a chance that if you are in this room today, you have heard before, like MPLS, BGP, ISIS, IPFix, the Young modeling language, segment routing. At the beginning, it was a very, very frightening experience for me, because it is a very instinctual thought. You are in front of the demigods of the internet, and the first thing you think is, what can I possibly say to these people that these people didn't already think? What can I contribute? And this is especially true for me because, as I was saying, I am Italian, and I come specifically from South Italy, from the city of Bari in Puglia. Don't know if you have heard about it, where there is a prevailing, what I call, push-down culture. So there is no attempt to let people emerge, right? There is actually a subtle invitation to stay average, or what we say, stay normal, right? And this is especially true that in our dialect, in Italy, every 50 kilometers you have a different dialect and things like that. We have a way of saying this, like stay normal, stay average, and that is Chadashi Facheng. No worries, translators. I will translate it in English for you, and then you take it from there. It means, who do you think you are? So why I wanted to take you to that room and why I was there, presenting. In order to say this, we have to take a step back, to probably 25 years ago, to, let's call it a network observability 1.0, 1.0, MRTG graphs, right? And 25 years ago, I started my journey in data collection. And this, to be honest, it will be a story that will be a lot around data collection, under the lens of data collection. On one hand, because it's my specialty. On the other, it's because data collection is, who is not doing data collection today? You are all doing data collection in a way or in another in this room. So back then, I was working for a small internet service provider in Bari, in my city. And, we just, the traffic was growing. And my management came to me and they said, hey, dude, I mean, let's gain some insight, because traffic growing, I mean, it means there is more cost. So let's see where this is coming from and going to. So out of operational needs, I essentially did build my own network traffic collector. And this would have become, a couple of years later, the first incarnation of PMSCCT software. What is PMSCCT? Since I mentioned it already a couple of times, is, as I was saying, my own data collector. I started writing it at the beginning of the 2000s. And since the very beginning, it was free and open source. It is a piece of software that is still maintained and developed today, intercepting all the latest trends and the standards. So it's not something that died, 25 years ago. So I would say it's still developed today. And it distinguishes itself because of its unpronounceable name. I challenge you to say PMSCCT, especially after a few beers. And its distinctive, angry octopus logo. It's a data collector where, that it can be used to collect, S-flow, NetFlow, IPFix, this already from 25 years ago. Then it got enriched with new protocols like BGP, BMP, and more recently, incarnation of the next generation streaming telemetry, like YangPush. And we will talk about YangPush later. You have a GitHub link there. Why I started to write PMSCCT, it's simply because back then, in year 2000, there was no existing tool that could allow me to aggregate and manipulate, the data, as the network traffic data as I wanted. So the only way was to write all the data to disk and then, mine this data. But I didn't want to break the bank of my employer, and then, mining, gigabyte or terabyte of data in year 2000 was also very expensive. So what came to the rescue was a Cisco NetFlow. So we were lucky enough 25 years ago to have to run our backbone with the Cisco 2500. And these Cisco devices, they were running this protocol, Cisco NetFlow. If you are not familiar with the protocol itself, no worries. I'll give you a primer in just a couple of sentences. So it's a protocol where you can build a cache on a router. So every packet that is going through the router, it gets summarized. It gets summarized like a quintuple, for example, like source IP address, destination IP address, source port, destination port, IP protocol. And then, bytes and packet counters get summed. Then at some point, this cache gets expired, and then a collector can receive this data, and you can keep this data historically or manipulate it as you prefer. Now, let's start talking about standardization. Cisco NetFlow was a technology from Cisco, and Cisco NetFlow got openly documented in 2004 at IETF. IETF, let's recall what we were saying before. It's the Internet Engineering Task Force, which is essentially the factory that prints Internet standards, right? So BGP, ISIS, and things like that. So why Cisco did that, right? On one hand, we can say that Cisco did it for the benefit of the wider Internet community. But we are not all angels, of course. And so, on the other hand, it was just a smart move to make it become a de facto standard. So the moment in which you openly document something, then your competitors, so the Nokia, the Juniper, the Huawei of this world, they can just copy-paste these specs in their routers, and here you go. You just rebrand it, you call it in a different way, you call it C-Flow, J-Flow, NetStream, and essentially, it's all the same thing. So this is the moment in which NetFlow started its journey in IETF. So there was, at some point, a beauty context, because NetFlow was not the only protocol existing at that time to do this, so to collect traffic flow and export them. It got selected as the base protocol for IPFix. The IETF protocol for IP flow information export, which is a generalized and improved version of NetFlow. And IPFix became a standard quite a few years later, let's say, in 2013. Today, we can say that IPFix is ubiquitous, right? So any edge device that connects to the internet essentially supports IPFix. And if some device doesn't do that, I recommend you don't buy that device because you would be blind. You would not know, where the traffic is coming from and going to. I did learn that 25 years ago. Anyway, so during these 15 years, so from the start of my journey in year 2000 to 2013, trust me, like as a developer of a collector software, I have seen a lot. I have seen really a lot of stuff. And all mainly was boiling down to, liberal interpretation of what is good. Because the moment in which you write a spec, of course, in the spec, there are some gaps. And you have to fill these gaps. And one engineer can think that, filling these gaps can be good to do it in one way, and another engineer can do it in a different way, right? So, and all of this was mainly boiling down to the fact that the Cisco NetFlow specification from 2004, they were not the most complete. Also because Cisco NetFlow was a protocol that was, just serving some use cases back then. So the net effect on my software was that I was unable to have just one pipeline by which I could collect all the data from all the vendors. I had to have giant if-then-else clauses. I need to do heuristics, try to hint which kind of router is exporting this data, and things like that. So if you know a little bit about software, so making the code longer and more complex, it has some implication. It needs more time to develop. The code can be more prone to bugs. You need more time to test. So all of this, it means more time and more cost. And this is just, let me put it in between quotes, just a monitoring protocol. Now you guess whether you take the same approach for a routing protocol, right? Consequences would be disastrous. And you could add very well, missing SLAs, penalties to pay, a lot of other fun to just, bugs. So the first key takeaway that I would like to offer you today is that the internet, in order to work in a reliable, cost-effective, and stable way, it needs standardization. Its foundation needs standardization. OK. But how does standardization work, right? So, like we said, it's a collection of specs, right? So you start by writing a document. And you start by writing a document because you have got an idea. It's not that kind of cool idea that you would have, in the morning, you are singing under the shower. I mean, that is the kind of idea that makes you rich, an entrepreneur, and things like that. This is a different kind of idea that you get here. Typically, you have a problem to solve, and you are an operator, or you are a vendor, or it's an operator working with a vendor. And essentially, there is no available specs to resolve your problem. So what do? You just write new specs, right? And so what you do is that you start with a document, and then essentially you go by iteration, and you collect feedback, support, new ideas, criticism, editorial changes, nitpicking, and you drive this document to completion. Eventually, it will become an internet standard, right? So no document in internet standardization, and specifically at IETF, it's just a simple one-liner. It's just like, oh, a bit is 0 or 1, and you just say one line in a document, the bit will be 0 or 1. No, not absolutely not. So first, you have to keep in your mind that who may be reviewing or reading the document may totally not be familiar with the problem space that you are talking about. So you need an abstract, then you have to have an introduction. Then for sure, the core of the document, it's technical. So you explain the motivation of your work and things like that, and then you say at some point that, I don't know, this bit should be 0 or 1, right? And of course, whatever thing you define in a standardization document, you are touching a number of moving parts that are already existing. So every document needs operational consideration, security considerations, standardization consideration, because you may be touching something that was standardized before. So you see, it's a chain. And of course, you have also to contextualize the work that you are doing with existing work that was done before or that it's been done. So you need essentially bibliography. So this is to say that even the definition of one bit can take, I don't know, 5 pages or something like that. Speaking in terms of time, defining, a single bit, like, you can see there the bit, the 0 or 1, you have an existing protocol. This protocol is part of an existing stack of protocols and things like that. You want just to define one bit to change the behavior of this protocol. Well, the iterative process of standardization can very, very likely take even 1 year to complete. And let's say that instead you want to edit a protocol, so you want to improve a protocol. I mean, you have version 3 and you want to make version 4. So there will be some changes. So it's not just one bit. There will be, I don't know, a new header, a new field. There will be a number of new improved different compared to the current version. And this can take even tens or 20 iterations. So it means also it can take a few years. And imagine instead that you want to define a whole new protocol from the beginning. Well, this can take even more than a few years, let's say 5 years. So you see, the thing is that you have pros and cons with standardization. On one hand, it's a time-consuming iterative mechanism. On the other, it's a structured process that delivers high-quality output. Having looked at the same matter from different angles, also from reviewers will be with different backgrounds and probably from different parts of the industry. So you see, it's not all perfect, right? You have one thing and you have the other thing. But let's remember the takeaway that I offered you before. What would be the consequences of labeling, standardization just as a long and a complex thing that, we are better be a little bit like, I give you my API, you give me your API, and then we normalize the data and we are going to somehow figure it out, right? Well, doing this with the foundation of the internet, with the protocol definition, can have some consequences that are disastrous. So I really think we should stick to standardization. I'm in favor of standardization. We should not drop the ball on it and just deem as a complex structure. And now I want to tell you a story from 20 years ago, more or less, right? So it was year 2008 when I attended my first ITF meeting. I recall that the meeting was in Maastricht. Maastricht is in the south of the Netherlands, and I was living in Utrecht, which is a city in the north of the Netherlands, right? The Netherlands will be probably smaller than one state here in Brazil, okay? So it's not very big. So, you know, I was there, and my employer was not supporting me in my curiosity for ITF and things like that. So everything was aligned for a punk trip, you know, down in the country. So like jump on the first train of the day, have a nap, always with that bare level of attention so that I will not wake up in Belgium or in France, for example. And then, you know, attend the event, and then at the end of the day, go back with the last train. I went there mainly to attend a side event that was being held in the belly of the ITF meeting. It was the IPFix workshop. You see, IPFix is coming back. And let's remember, this is year 2008. IPFix is a protocol that became a standard in 2013, and the journey of standardization started in 2004. So we are pretty much, you know, in the middle of that. Back then, I was already for some years in data collection. It's a very niche kind of environment, so I was super excited to connect with people of the same breed. Other people that they were collecting data, or even better, you know, they were on the other side of the fence, like data producers. So my takeaway from that event that I want to offer you is that it can be very tempting to do, let me call a club solution. So a solution that works for me and my club of customers, right? Which is what, you know, Sysconnect Flow was before. But what was happening at that workshop was far greater. So a protocol that was a proprietary technology got openly documented. It was given to the community. We can totally say it was given to the community. And then a few years later, it got standardized. And at my very first participation in an ITF meeting, I was absolutely Mr. Nobody. I was not supported by my employer. I was just a random guy that was developing a free open source collector and had only some operational experience with the NetFlow and with what was the germs of you know, this new protocol that was being defined. And I was very much welcomed. People were asking also my opinion. They were, you know, involving me in understanding how can we make this better. So I don't know if you agree with me, but you know, this is a brilliant story. It's a fascinating and inspiring. But sometimes things can go differently. And I don't know whether I am already on the next slide or not. Let's see. OK, I don't know which slide I am, but OK, yes, I was on the right one. So things, as I was saying, can go differently. So let's fast forward for a few years to tell a different story. So we close the page of NetFlow and IPFix. And we go to February 2019 to San Francisco, where NANOG 75 was held. And you can see there in this picture that I was there. I was with my Atlético Nacional from Medellin jumper. And, well, it was a terrible moment. I mean, River Plate just finished, getting the Libertadores with Franco Armani. And they got Franco Armani from Atletico Nacional. He left us in misery without a good goalkeeper for a good few years. But in any case, that's life. So back to our story. So I was just, listening to this presentation from a Cisco guy. And this guy, believe me, for 30 minutes, this guy was saying, oh, the G product this is great. Oh, the G product that is wow. The G product here, the G product there, and whatever. And he was referring to gRPC, Google Protobuf, GNMI, GNOI, grib, and whatever. And I felt compelled after 30 minutes to go at the microphone and ask, sorry, can you remind me for what company are you working for? Are you working for Cisco? And he said yes. And I said, oh, strange, because I thought you were working for Google. The people started chuckling and things like that, but this marks an important moment. So let me give the due context around this moment, right? So Google is a company which has a big spending power, okay? And Google identifies the urgent need for next generation data collection. For the nerds about us, we typically collect infrastructure data with SNMP. SNMP is a polling technology. What is polling? You send a request, you get an answer. Polling is slow. So what we needed was a way to stream data from out of devices. Okay, we want to stream this data in a structured format. So like we don't want strings, random stuff, and whatever. So we want kind of a binary format. And most importantly, we want this to work fast. So essentially, what happens is that, let me offer you this timeline. In 2019, when all of this happened, you can see that ITF was already working on that. So in this timeline that you can see there, already before 2014 in ITF, there was, let's say, there was the definition of subscription requirements, of what is a dynamic subscription, what is a static subscription, all of this, all the super foundation, so that you could have a streaming kind of technology. But no, Google decides to form a club, and this club is called OpenConfig, in case any of you knows it. And they put together a non-standard stack. And initially, to be honest with you, this non-standard stack had also some design flaws. So for example, I said, you want structured data. Structured data follows models. But in their architecture, like the models, you had data schemas on top of models. So you had, when data was going on the wire, had a schema, and that was not exactly the same thing of the model. Another flaw was that it was not clear how these schemas should be exchanged between, an exporter and a collector. It was built mostly reusing existing components that they were developed for other stuff, like, for example, gRPC, and of course, prioritizing integration with the own programming language of Google, the Go language. So what happens, guys, and this is a key moment, right? So Google sells not Google, let's say, the club, sells this solution to some lazy vendors. So when I say lazy vendors, I think Cisco, Juniper, Nokia, right? They just go and say, guys, you have to implement this thing. And you know what happens? These companies, the Cisco, the Juniper, the Nokia, they do it. They just implement it. This thing is not perfect, it's not flawed. They don't really ask questions like, is this a standard? Is going to become a standard? What are your ideas? And spoiler alert, like GNMI, for example, and other products of OpenConfig, they were never offered to the community. I mean, they are still today not a standard. And why the vendors did that? Because let's remember, we have a big potential customer with spending power. They form a club with other big logos and things like that. All the vendor wanted in that moment was just to be compliant with RFPs. RFPs is that kind of document that when you have to buy a new device from a vendor, you give this document and you say you have to be compliant with all of this. So they were saying like, you have to be compliant and you have to have the OpenConfig, stack in your router. And if you don't have it, then essentially you are not compliant, so you are out, and we will buy from a competitor. So you see the vendors, without asking many questions and whatever, they essentially implement this thing. They fill themselves the mirage of an upsell, and you see the circle is closed, right? So you have influential people with power, and the vendor, they are just executing. Now, let's think about two facts. One is that the club, in order to be successful, it must work in a pragmatic way. Business-oriented, delivering results, and most importantly, pushing its own objectives over anything else, with the risk to convert what are typically contributors into followers. The second thing is that, like I was anticipating before, Google never wanted to submit a GNMI for the process of Internet standardization at IETF. So what IETF had to do was simply to continue following its own path. So IETF is developing a new, a different technology for the exact same thing. And this technology is called Young Push. You can see here that there is a slide of the architecture of Young Push. We are not going to go through it because we don't want to make it very, very technical. But this is for, for your reference for later. And today, you can start to find parts of Young Push, and we will see why parts of Young Push, in some router vendors like Cisco, like Huawei. This technology is defined with only IETF community components. It's very rich in features, generalized, and agnostic to transport and encoding. So you see, we have two solutions. And let me start from the most important thing, that this talk is in favor of having alternatives, right? For me, Paolo, personally, two alternatives, it's a no-brainer. You always need two alternatives. Think, for example, to SPF and SIS, right? It's a no-brainer. Two, you always need. Three or more, it depends. I mean, it's more a case-to-case basis. Maybe you can fragment the cone of audience too much, or maybe you need three or more solutions in order to prevent cartelization. And here, maybe more than internet, we are thinking about, I don't know, transport, aviation, and things like that. So competition, it's absolutely a healthy and a very powerful engine. We need it, and it fosters innovation. What this talk instead is about is to encourage all of us to stay vigilant on the formation of oligarchies. that are trying to define key aspects and foundational aspects of the Internet, either Internet itself or its operational aspects. And let's remember that Internet is defined by UNESCO as a global public good, and for which it advocates multi-stakeholder participation. So in the end, let's go back a little bit to more technical aspects and less philosophical ones. Having this slide in mind, you see you have these two sides. We must say that the OpenConfig ecosystem, it has been, over time, being very lean at the beginning, and it has been absolutely growing and improving over time, absolutely. So it's not the same thing that was firstly implemented in rush from the vendors. No, it's becoming something with a traction, with a market, and it's being improved and reached and whatever. But guess what? At the very same time, the rich ecosystem that you saw in the previous slide, that was the young push one with hundreds of things over there that are supported, is taking the opposite journey. It's going through a journey of optimization and simplification, right? Because actually it was a stack put together with the thinking, with a lot of specification, thinking to a lot of cases and a lot of stuff. And of course, what happens is that if you have something complex, then it's difficult to implement. So the journey backward. So as you see, we have almost two universes that are taking the journey in opposite direction. Probably they will meet somewhere at a midpoint at some point. So this leaves us with a question. And when streaming telemetry will become a commodity, which is totally not the case today, because you see there is a lot of bubbling going on here. Will it be a new case of 6 versus half a dozen? Or in other words, two equivalents of the same thing, right? Because let's remember of this journey in the two different directions. So with this question, let's start wrapping up. I have my last, I think, 4 minutes. So let's start from the end of the remark at the bottom of this slide. Let's meet at the happy hour how we are going to order our 3 rounds of beer. 6, half a dozen, I don't know. So, I really wanted to come here on stage today, and instead of entertaining you for, now it's 40 minutes, I really wanted to make a 2 minutes presentation and say, guys, you know what? We have got artificial intelligence, and AI is going to resolve everything. We don't have to talk about standardization, nothing. I mean, AI will take care of that. Unfortunately, this is not possible because, protocols are so, foundational. They are as foundational as, a language, right? So essentially, like, they live really layers and layers down, for example, even of an artificial intelligence. And so they actually make it in a way that artificial intelligence, like nodes of clusters, they can communicate with each other. So ITF, as we have seen, we have spoken about standardization a lot. It's not perfect, right? It's not perfect because it lacks of the agility and incremental development to get closer to business needs, right? To work in a kind of a minimal viable product kind of way. This is essentially the reason why we have seen, the formation of a separate club that actually wanted to work in that, pragmatic way. But the the good thing, the good news is that at ITF this is being discussed, and let's say this specific thing has been identified. And it was, in fact, among the outcomes of the AIB meeting. AIB meeting in ITF is like those meetings where ITF gathers together with operators and different people in the industry to see what did we nail and what did we not nail for the past years. And one of the outcomes was exactly this. We need to work in a more pragmatic way. But the most important thing of ITF is that it embraces a decision-making process that balances the pragmatic, just getting the work done, with making sure through all that structured process that I described before, that issues are discussed, and most importantly, that everybody have had a chance to explain their concern. This is super important, right? So, as a very last word for today, I want to recall that Internet standardization, it's not just me, it's not just the demigods that I was mentioning at the beginning of the presentation, but it's all of us, it's also all of you. And I really want that this is another key takeaway for you today. To participate into ITF, you don't need money or travel, not necessarily, right? Everything is structured and organized so that you can participate in every aspect of ITF, from the beginning to the end, from reviewing to proposing ideas and everything, from your office or your couch at home, right? Of course, every now and then there will be a meeting in Australia, and you want to have a speech at that meeting, and you are in Sao Paulo, you didn't travel, so the meeting will fall in the middle of the night. But that night you just drink one beer less, and everything is going to be fine. So what really you need in order to participate to Internet standardization and ITF is commitment and time. So if you have those, especially time, which is one of the most precious resources, probably the most precious resource, please don't hesitate to contribute to Internet standardization, because that will be for the benefit of the greater Internet community that, in the end, it's about all of us. Thank you very much.